In this video, we are going to talk about the different types of matter. All evidence is matter. All evidence is matter. Now, there are three states of matter. The first is a solid. Now, a solid is going to have a definite shape and a definite volume. A solid is going to have particles that are very close together, as you can see here. And they aren't moving very fast at all. To our eyes, it looks like they're not moving at all, but they are. Now, the second type or the second state is a liquid. And a liquid is going to have a definite volume, but it does not have a definite shape. So, an example of that would be something like a glass of water. That liquid in the glass of water has a definite volume. I can measure the volume, and that volume will stay the same regardless of where of the container it's in. Now, the shape will change. If I have a glass of water, it's going to take on the shape of that glass. But if I say take that glass of water and pour it on my son's head, then that shape is going to take on the shape of my son's head. It will still have the same volume, but it's going to have a different shape. As you can see here, the particles in a liquid are going to start being a little further apart and they are going to start moving a little faster. The third state of matter is a gas. Now, a gas has no definite shape and no definite volume. So, what that means is a gas will fill a container completely. So the volume of a gas is going to be whatever container it is in. If you compress your container, then the gas will also compress and the volume and the shape will change. Now, gas particles are much further apart than solid or liquid, and they're moving much faster. Now, the difference between these three states are how the particles are behaving and how they are moving. And we can manipulate that by adding heat. If we add heat, we can change a solid to a liquid. And if we continue to add heat, then we can change that liquid to a gas. Now, if we start removing the heat, then we can change the gas to a liquid. And if we remove the heat even more, then we can change that liquid to a solid. So these are the different states that matter can take on. Now, matter there's two types of matter. There are pure substances, and a pure substance is going to have uniform composition. And there are two different types of pure substances. So we have elements that only contain atoms of one element. An atom is the smallest unit of an element. So it is the smallest unit of an element that retains the properties of that element. All right. The other type of pure substance is a compound. So compounds contain atoms of two or more elements. So compounds are going to be when you start putting these different elements together, they're going to have new properties. So here is an example of sodium metal, and you can see we only have one atom in here, and it is a sodium atom. Here is an example of ethanol. It's made up of carbons, hydrogens, and oxygen. So we have different atoms that make up this compound. Something you need to really be aware of is if you change an element or a compound, then you change the identity of that pure substance. Now, the other type of matter is a mixture. So a mixture is when you take two or more pure substances and you mix them together. We have two different types of mixtures. We have homogeneous mixtures. So in a homogeneous mixture, the composition is uniform. So what it makes up the mixture is going to be uniform throughout the mixture. So what that means is it's going to be the same throughout the mixture. Common misconception is that a mixture has to be liquid. That's not the case. Steel is a great example of a homogeneous mixture. Rain is an example of a homogeneous mixture. Air is an example of a homogeneous mixture. And wine is also an example of a homogeneous mixture. Other examples might include something like milk. When you buy milk at the store, most of the time it has been homogenized because the fat and the liquid have been mixed together. And they can be mixed together in different ratios to give you different percentages of fat. Now, something that is also unique to homogeneous mixtures is that the samples of a homogeneous mixture will be the same regardless of how many samples you have, and it'll be the same as the original mixture. So an example of that might be a pitcher of Kool-Aid. The pitcher of Kool-Aid is going to have the same uniform composition as if I were to pour some Kool-Aid into different cups. All of the cups and the mixture within the pitcher are going to have the same composition. Now, the other type of mixture is a heterogeneous mixture. A heterogeneous mixture is not the same throughout. So the composition will vary. So some examples of homogeneous mixtures would be cereal and milk. So you can see it's not going to be uniform. Every bite of cereal I take is not going to be exactly the same. So samples of a heterogeneous mixture are not going to be the same as the original mixture. When you have ice and soda, or it is going to be a heterogeneous mixture. Soil and blood can even be a heterogeneous mixture as well. So let's look at some examples of, oh, here's a flow chart that shows you the different types of matter. So everything is going to be classified as matter. And we have two types of matter, pure substances and mixtures. Now, the pure substances are going to be elements and compounds, whereas the mixtures are going to be heterogeneous mixtures and homogeneous mixtures. Now, like I said before, if you were to change an element or a compound, you would change the identity of the substance. So a change results in a change of identity. So if I have a compound, say water, which is H2O, and I change that and I take one of those hydrogens away, one of those H's away, I have now changed the identity. All right. This OH is very different than H2O. With mixtures, the change does not result in a change of identity. So, for example, if I have my Kool-Aid and I add more water, then I still have Kool-Aid. It's just been diluted, but I have not changed the identity of the Kool-Aid. I still have Kool-Aid. If I take salt, NaCl, solid salt, and I mix that with water, then I make a salt water solution. I make a sodium chloride solution. Notice I still have sodium chloride. It did not change the identity of the sodium chloride. It did not change the identity of the water. I have just mixed them together. If I needed to, I could use a separation technique and get my substances back. So let's look at an example. Classify the following substances according to their type of matter. Go ahead and pause the video, see if you can figure out the answers to this, and then come back and we will go over it together. All right, hopefully you paused the video and we can go over these together. Sugar. So sugar, C12H22O11. This is an example of a lot of different atoms bonded together to make a compound. So this is going to be a compound. Notice we only have one substance, sugar. It's not mixed with anything else. It is also more than just one atom, so that's how it is a compound. Now, carbon is all by itself. This is an element. Coffee, when you drink your coffee, it is going to have a uniform appearance. It is going to be a homogeneous mixture. And then finally, seawater with sand in the bottom. We have our seawater and we have sand, so that's not going to be a uniform appearance. So it is going to be a heterogeneous mixture. It is important that you can identify different substances with the different type of matter that they are. Chemists use what is called thin layer chromatography, or TLC, to separate mixtures. So this is an example of a pen. You can see we have these dots here are different black pens, and you can use a mobile phase and a stationary phase. So the mobile phase is going to be the solvent down here, and it's going to move up the plate. And as it does move up the plate, you can see all of those different colors start separating out. So these different inks have different, or the different black inks actually contain different colors. This is very, very important for drug analysis. If you want to try and see what type of drug someone has in their system, TLC can be used.